If you've ever played The Last of Us or seen the show, you know all about the terrifying clickers. But what if I told you the fungus they're based on is absolutely real? And honestly, its true story is even stranger, and maybe even more terrifying than fiction. So let's dive into the absolutely wild world of cordyceps.
This one line just sends a shiver down your spine, doesn't it? It perfectly captures what happens to an insect that has the bad luck of crossing paths with this fungus. This isn't just about dying. This is a complete and total hostile takeover of your body while you're still in it.
All right, to really understand this, let's follow the journey of one single carpenter ant. Picture it. It's high up in the canopy of the Amazon rainforest, just going about its day. But its life is about to take a seriously horrifying turn. It all starts so quietly. A single microscopic spore just lands on the ant's back. It's completely invisible, totally harmless, or so it seems. The ant has no idea. It just keeps on working, completely unaware that a biological time bomb has just started ticking away inside its own body.
And the takeover is just brutally precise. First, the infection spreads, causing the ant to start twitching and convulsing, and it falls from the safety of the canopy. Then, a chemical cocktail hijacks its instincts, forcing it on this final zombie-like march. It's compelled to climb a plant stem to a height of exactly 25 centimeters off the ground, the perfect altitude for the fungus's preferred humidity and temperature. There, it's forced to perform the final act, the death grip, biting down on a leaf for the force it never had in life. And only then, once it's locked in place, does the fungus finally kill its host, erupting from its head to rain down a fresh batch of spores on the unsuspecting colony below.
Now, for years, scientists pretty much thought they knew how this all worked. But some recent research has uncovered this huge plot twist, and it's changed everything we thought we knew about this parasite. This was the big mystery, right? How does the fungus actually control the host? If the ant is being forced to move against its will, what's pulling the strings? Well, it turns out the obvious answer was completely wrong. So the common belief, the myth, was that the fungus just grows into the ant's brain, basically turning it into a fungal joystick to control the body. Makes sense, right? But when scientists actually looked inside, they found the exact opposite. The brain is one of the only places the fungus actively avoids. It's left almost completely intact.
And here it is. This is the big aha moment. The fungus isn't a brain eater. It's a puppeteer. Think about it this way. It leaves the pilot in the cockpit, totally aware, but it cuts all the wires to the controls.
Fungal cells literally weave themselves all throughout the ant's body, creating this interconnected biological mesh that wraps around the muscles. This network seizes direct control of the ant's limbs. So the ant's brain might still be screaming signals, turn left, go back to the nest, but they're completely drowned out. The fungus is driving the car, and the ant is just a prisoner locked in the back seat, helpless on a one-way trip to its own doom. You know, there's a really cool scientific term for this whole phenomenon. It's called the extended phenotype. It's this idea that an organism's genes can build something outside of its own body. So, a bird's genes build a nest, a beaver's genes build a dam, and this fungus's genes build a walking, spore-launching zombie puppet out of a completely different creature. It's incredible. Okay, so as horrifying as all of that is, you might be surprised to hear that humans have actually been seeking out these fungi for centuries, and not because we see them as a threat, but because they can be an incredibly powerful medicine. Now, we've got to be super clear here. We are not talking about the exact same species that creates zombie ants. The Cordyceps family is huge, with hundreds of species. The ones used in medicine, like the famous Cordyceps sinensis, have a very different relationship with their hosts, and thankfully, with us. These fungi are basically chemical factories. I mean, one of modern medicine's most important drugs, cyclosporin. It's the stuff that literally prevents your body from rejecting a new organ after a transplant. That was derived from a related fungus. And today, Cordyceps is being studied for literally everything from anti-tumor properties to boosting athletic performance. The very same chemical power that can hijack an insect can also help heal our own bodies. So it begs the question, why does nature even create something so brutal? It's really easy to look at this fungus and just see a monster. But if we zoom out and look at the big picture, we start to see it plays a crucial role in the health of the entire rainforest. You can think of this fungus as a natural system of checks and balances. By targeting the most common and dominant insect species, it prevents any single colony from completely taking over the forest floor. It's like a grim reaper that, weirdly enough, allows for more life and greater diversity to thrive in its wake. And now we get to the question that's probably been on your mind this whole time. Could this happen to us? Are we next? Well, for right now, the answer is a pretty solid no. And our greatest defense is actually our own body heat. Our constant internal temperature of 98.6 degrees Fahrenheit, or 37 Celsius, is basically a furnace for most fungal species. It's just too hot for them to handle. But here's one last little thought to leave you with. As our planet gets warmer, all living things, including fungi, are going to be under enormous pressure to adapt to higher and higher temperatures. That thermal firewall that protects us, it's shrinking. And as that gap closes, well, who knows what a few million years of evolution might cook up next.